So today I will go through what we have done in the module overview of the course, where we discuss about the theory and also practical aspect of relational databases using Oracle. So first of all, I would like to start from the classroom environment. I want to just make sure that you have received everything what I have shared. So the first one, if you go to classwork, you can see I have posted marks, all the scripts that we have discussed, and also the new one, which I'm going to discuss today. Some of the things also here. So I hope you have access to all this information. You can just look at the coding. When you click on that, it will open up and you can go through what we have discussed in here. So I have given you full script so that you are familiar with this one. And also I will explain today what those. It's a comprehensive one. We are starting from simple database creation to we discuss advanced queries, right? So everything is uploaded by now. So hope everything will be available. So when I use the today's scripts, so you can refer it from here. So that's the first part. And then also you will have access to all the quizzes when I shared. Right now, I have not shared online, but I will give you once we finish today's session. I will make it available, all the 4 quizzes assigned to you, so that you can try and come for the final session we are going to have tomorrow. Right now, I will compile all the questions together and I will give you it as a single quiz for today, which consisted about like 40 questions. For tomorrow's session, we'll get about 60 questions. Yes, Bhagya. Bhagya?
Sorry, sir.
Okay, it's okay. Yeah, so I thought like you're asking something about the quizzes. So that's what we are going to have. So it will be a similar format, except that now we have covered everything. So the questions will come from day 1 or from session 1 to session 6, that is including what material we covered in today's sessions, right? So you'll get 60 MCQ questions to be answered within 2 hours time. All the handouts also I have put it here. For example, today I have given you the last one. If you refer this one, this will be the last discussion, which I'm going to discuss today. So the last time we discussed up to, nested queries. We'll focus on the correlated queries. I will explain what those are. And then also different operators, use of nulls in SQL queries, renaming. I have particularly discussed use of joins compared to selection and join conditions. And finally, we also discuss aggregation, grouping, and finally we are going to discuss talking about the order by. So this is also I have uploaded last time so that you can have a look at. I have given you complete set of notes for Oracle SQL. And also I have also shared with you all the video recordings so far. So in case if you missed anything, you can again refer back what we have done. So that's about my Google Classroom part. Second one, let me share like how the questions look like. So for example, this is the 4th one for all the questions given to you so far, right? all the 40 questions given to you for here, from starting from what is the relational database, it will consist of all the advanced queries we had discussed. Right now, here we have up to the advanced queries we have included. So by practicing this, hopefully you will get an idea what kind of a questions you might get in tomorrow's session as well. So get familiar with the question format. In case we can run about like 10 minutes, is it okay? Shall we have a quick run so that hope everybody is familiar with this system? Just let me know in the chat. We can have a quick 10 minutes just for practice. Saumya, yes. Okay, we'll have a quick random 10 questions. Okay. I want everybody to join and let's practice, because this is the same format I'm going to use tomorrow, right? Okay, so I'm going to open up. I'm going to host live. Okay, one thing I want to get from you is put up your employee number as the nickname, because this is what we are going to track, right? Remember to use employee name, and employee name will be using for marking and everything. In case if you have used multiple ones, just let me know so that I can correct you. Okay, so when you want to connect, I hope everybody is familiar. You have to go to www.kahoot.it. This is the platform, and you have to enter the pin 207 48 59. Okay. So what I'm going to do is how many participants we have today? We have 42. That means excluding myself, there are 41. If you can make it quick, it'll be easier. Let me say, can you all log in within another 2 minutes time? Thank you. So I'm not going to record this part. So let me quickly go through what we have discussed so far. In our first session, we discussed about what relational databases are. We know nowadays data could be in multiple different forms, which nowadays we call data lakes. We can keep as it is. But most commonly used one is called structured data. That means we keep data as tables, and that's the keep data as related tables. And that's what we discuss under the relational databases. So in the first few sessions, simply we discuss about how we are going to do this. So in first few sessions, we talk about the basically theory, introduce the system. Second and third, we discuss about the data modeling and also converting from conceptual model to logical model. And then we started looking at how we can implement using SQL. So in the first few sessions, we talk about creation and simple querying. And last session, we started looking at some advanced SQL concepts, the queries. And today I'm going to continue with that. So the last session, as we discussed early, we are going to use case study assignment. Right. So having said that, I think that part is okay. And throughout the course, actually, I have used Navati's database book, and the example is also the same. So that's why we talk about like, for example, company database. So that part we have covered. And another thing that we have covered is database process. For example, if you're designing or if you're using database designing, what are the different phases? That also we have discussed. For example, everything here we have discussed except the tuning and also implementing part, which is with some other programming language. That part I didn't do, but all the other parts I think we have discussed. Of course, we have not discussed the requirement collection, but Within that, we have covered all these 4 topics. For example, conceptual database design discussed with ER, and then database management system choice, we said it's Oracle. And then we discussed about how you map the model and created the SQL script. So those parts we have covered in our first few sessions. Right. And then, yeah. So main thing we have discussed under this is use of ER modeling, come up with given a database requirement like this, to come up with a diagram like this. And I told you the importance of this, because especially when you are presenting your design to your board, your colleague, and then your customer. So you need some kind of a graphical representation, and this is one of them we discussed. There are many others, but very simple one we discuss. I hope everybody are now familiar with this. This is called the conception model. Then the next step, we have to convert this into schema. So take a picture of this in case if you want, because for advanced queries that we will write today, it might be helpful if you have these graphs with you. Okay. Then the next one we discussed is the mapping part. Simply once you given ER diagram, then we discuss how we can convert ER diagrams into what we call the logical model. So once you given this, we discussed, right, how you may convert into this model, that means that this conceptual model, that is ER diagram, into a relational schema, we normally call it, relational schema like this. So that is what we have discussed. That means converting your conceptual model to this. The third one is the SQL part. So the remaining parts, what we discuss is basic SQL statement. So the remaining part, we discuss what SQL statements are, different types of SQL statements, right? So we had a comparison, and mainly we discuss under the SQL 2 main parts. Data definition language, we have done it. That means creating tables and also primary keys and foreign keys we specify. All this we have discussed it here. But then the second one also we have covered. That means data manipulation, which means you can retrieve, you can update, you can delete data. That part also we have covered, but not this one. Simply, for example, creating databases and creating users, giving them authorization, whether they are allowed to read and write, we do cover, but we covered first 2 parts in SQL. So main thing that we have covered under this is how to create a table, and starting from specifying a table with the name and also attribute with different data types with some other constraints, things like not null. We discussed what it means. We say that, okay, you cannot have null values under the department name. And then we also specify primary key constraint, which means any table you have to define what the primary key is. And then optionally, if there are any other keys, we can use unique key to say that it's unique to the table. Then we also use foreign key constraint, which reference the other table. For example, here we have manager social security number. That means we say that manager social security number is a foreign key, which connect to the employee table. It will connect to the social security number of the employee table. So these are the ideas that actually we discuss. Then we discuss the attribute types. There are many types like this. And then also we discuss what might happen if you delete. This is also we talk about. For example, once you set up this connectivity for in-key, what might happen if you delete it, right? If you delete it. So for example, if you delete the department, what might happen to this foreign key? We say it should be set to null value. So that's what we say, right? Because it affects. If you do not put this line, that is also we discussed. We said that it's usually use a restrict mode, which means you are not allowed to delete without deleting or without updating, employee tables. So that's the normal practice. Okay. Then we discuss other things as well. Okay, so I hope you get an idea like what we discussed. So let me start my today's session. Okay, I think we discussed basic ideas like how to insert, how to delete, and how to update. I will take some of the example, just briefly discuss, and then we'll quickly go to implementation details. But I have given you the full script, so you can try it out. You don't have to wait until I discuss. So inserting, we discuss how to insert into a table. Few things that we have discussed is, for example, most of the time you can enter the data, especially if they have specified that character or string data. So you can use single quote, but especially for data, you can actually make, specify the data that you want to make it a format. So in this particular case, data we have in original data set, we have year, month, and date. So we have a user function to retain that information. Then in case if you have null values, right, you don't have to specify them. You can say that, okay, you can say, for example, what you are going to insert. For example, in employee table, in this particular case, we don't specify any attributes here because we are going to specify all the values. That is one way to provide insert command. Second way is if you give only several attributes, so you can specify those attributes here and provide related values. So those are the two types of insert statement that you can implement. Right. Okay, so this is what to say that what might happen in the constraint. So for example, not null is a constraint, which means, okay, you are not allowed to make null values. So you have to make sure that they are not violated. If you violate, then you will get error message, because once you have this, then it will automatically enforce, which means if you specify a particular attribute as a not null, then you have to enter some value for that, those columns. Okay, delete also same. In this particular example, we can directly delete an employee if his particularly last name is Brown. Second one, the same thing, but if you're using social security number. Third one, where we have what we call subquery, which means you have an outer query and then an inner query. For example, uh, if you want to understand what happens here, usually you start from what is inside. So here it says select department number from department table where the department number resides. Simply what it says is you are going to take the department number for research. And then here we say delete from employee where the department number in, and you are getting the department number of research, right? If you refer the tables, you will see it's 5. So simply it will delete all the employees who belongs to the research department. Right. Then updating. So you can say that updating a particular value, right? So you can use variables to what records that you want to modify that. And you can set the values that what will be the new value, right? So for example, if you look at this command, we say update project, set project location to Bellarray, which means you are going to change the project location and department number to 5, where the project number is stayed. So simply you are going to change project location and the department number, which means who controls the particular project, where the project number 10. So you change both the location and controlling department number. Okay, this is interesting. I want to discuss this answer with the practice, but let me explain. For example, let's say, okay, everybody is nowadays waiting for a salary raise. Let's say we want to provide all employees a 10% salary raise. So you can see how we have created the update. So we will say update employee, which means we refer that we are going to change the update table. And when you say set, what is going to update? And you can notice this one. What you say here is, okay, you get the salary. The raise is 10%, right? So that means 10% means 0.1. So 1.1 means what will be the final salary once we have a 10% increment? That is 110, right? So that means you are going to multiply by 1.1. So the current salary, you are going to multiply by 1.1 and you assign. Right? But remember, there's a selection here. So this salary raise, we are not going to give it to everybody. If you have these two lines only without this, then we are actually giving 10% raise for all the employees. But what we are saying here is, again, we have a nested query. So if you read the inner query here, simply you are going to select the department number from department where department name is research. So you select the research department. And we are going to update the employee salary by increasing 10% where the department number here. So this part will retrieve the department number, and those who are in the research will given a 10% salary rise. If you have any questions, just let me know in the chat. Thanks. Right. Now we have already seen some nested queries. As you can see, sometimes you can directly, if you know values, you can directly give you the, for example, if you look at our data set, right? So let me show you the data first. I think we have not showed you that. You can take a look at this as well, or you can have a screenshot of this. So the last one, I think we have, let me show you, see whether we have. I think one of the slides I have given you not this one, maybe the previous one. Somewhere I have given you the whole data set. Let me check. Right. Didn't I give you that? Okay, let me share that. So one is the total data set. I'm going to. So when you say nesting queries, then you have two parts of it. So we have inner query, which is this. So we have one inside the bracket and one outside this. And you can notice that these are not related. So we normally see in the next part, it's called correlated queries, which means sometimes the inner tables also, there's a relation between both outer and the inner. So this one we call inner query, right? And this is the outer query. So here we will check the department number for research department. You can actually write the script and see the answer. And then that is applied here. So in the outer query, you select first name, last name, address from the employee, where the department number in that value you execute from here, and that applies here as well, right? Which is what we call the nested queries. So sometimes you can write the code in various ways, including nested queries with nested query and without nested query. Both ways are possible. For example, this one is also you can written without specifying nested query. Simply you can make the join of employee and the department, and then you can have a selection and join condition where the department name is research. That's possible, right? It's a two different styles that we have employed here. Right. Then Next one is correlated query. The difference from the previous one is the employee, for example, here is also referred within the inner query. So for example, inner query contains things from the outer query, then we call it correlated nested queries. So for example, in this particular case, what we do is we want to retrieve the names of each employee who has a dependent with the same first name as the employee, which is what we are trying to get it from here, which we have discussed earlier as well. Right, then we can say sometimes you can use other SQL keywords like exist. We can use to check whether the resource is empty, right? So for example, in this particular case, we can say whether we are exist, and within that we can have an inner query, right? So retrieve the name of each employee who has a dependent with the same first name as the employee. So simply you say whether select all from dependent where social security number should be equal to employee social security number, which you match social name with the employee social security number, and first name should be equal to dependent name, right? Another example which uses the same. Then we can have explicit sets. For example, now let's say one way to get data is we can say, okay, project number equals and something. But then if you want to retrieve data about multiple projects, like in this case, we are going to get those who works on project number 1, 2, or 3. So you can see in operator, and then you can have a set of numbers. So that's what we say explicit set, which we can actually get the data from a database. Then null in SQL queries, for example, here we have retrieved the names of all employees who do not have supervisors. Okay, can you try to give me an answer for this? Without giving you, and without looking at the, yes. Okay, given this query, my first question is, I have already given you the data set. You can have a look at the data set now. Look at the data set given to you and tell me what are the tables I need to refer to answer this question. Let me see how many of you can give me the answer. Look at the table given to you. Okay, let me share the data set. Okay, can you tell me who is John Smith supervisor? Refer the data set given to you. Look at John Smith. Can you tell me who's John Smith supervisor? Yes. Okay. So remember John Smith is here. Supervisor social security number here. This is the, right? So this is John, and this is the social supervisor number 333445555. So go through the social security number. Right? So where's 333445555? John Smith. This is this one, right? Second row. Exactly. So now my question is, how do you write in SQL to get this? Yes. This is what we want to discuss. Yes, any ideas? If you know the supervisor name, this is what I want to discuss actually. If you know the supervisor name, you can say retrieve the name of employees, right? So you can say select the name of the employee. So you can say first name, last name, whatever you want to get. So you can say select first name or last name or the way you want. From which table? We have to refer only one table, right? So we have to say from employee. Okay. Third one is the interesting one. Where, okay, you have to say, we know that it's supervisor social security number, right? If you know the number, you can type it or you can say social security number should be equal to this. But here we have null value. So when you say null value, you can make a, equal sign. So you will check whether is null or is not null. So let me give you the answer and let's try to get this down in our SQL statement. So select first name and last name from employee where supervisor social security number is null. Okay, let's start practice this. Otherwise, some might not understand this. So you can see here when I say select all from employee, we get all the employee details. You can see we have employee's name and their supervisor social security numbers. Now, if you particularly interest of particular supervisor, given this number, in this particular second one, what we did, we select all employees who supervised by a supervisor with this social security number. So when I run this, we will observe that, okay, there are 3 employees whose supervisor is having this social security number. Okay. Right. Now, what I want to explain is if the supervisor is null, what do you mean? When you run this, you can notice. For example, if here there's no value here, we can say it's a null, no value. So how do you get that one? This is exactly what I want to discuss. So the next one is, we can say like this. We can say select first name, last name from employee where supervisor social security number is null. We don't say, right? We don't say right equals null. So that's what I want to highlight here. So we want to map it. So we don't say like this, it just say is null. And you can see that there's a person called James Bow who is without any supervisor. Okay. So I hope you understood that query. Right. Done. Those who have finished up to this point, just can you let me know in the chat? So in this one, what I'm going to do is I'm going to talk about the renaming attributes. Sometimes it's very important. For example, here we have F name. But we will say when you are presenting, let's say I want to say it as first name. Right? And then let's say L name, I will say last name. You can notice that I have used another keyword called as keyword. This is very important. And we'll say from employee, where I'm going to use the same query, supervisor social security number is now. Now let's run and observe. I'm going to select this and let's run. You can notice now we were able to renaming that. So this is where this keyword is useful. Right. Now, sometimes you might have noticed is some other, if you're familiar with some other database systems, this same thing could be used to rename your table as well, but it's not possible in Oracle, right? Let me show you a place where this is very useful, using both renaming attributes as well as renaming your tables, but renaming tables are not done with as keyword. So let me explain what I'm trying to explain it here. So let's say I want to retrieve names of employees with their supervisor names. How do you do that? List name of the employee and name of the supervisor. How do you do that? Bit difficult, right? But it's not that difficult if you think it right. This is where I want to think now, since you have already given you the data set, right? How do you get that one? Yes, anyone? Can you think of a way of getting employee names together with the supervisor name? I say super only, right? Supervisor name, supervisor name. Okay, we know this. Let me start from the beginning. Let me explain. So let's say we have everything. When you say select all from employee, you know that what we are getting is we get first name, last name, and also supervisor social security number. So in case instead of all, let me put this into the second line. And let me put this, okay, I will put like this. First name, last name, supervisor social security number. And okay, so now if you put this, let's see what will happen. If you run this, now you notice we have limit our discussion. We will list first name, last name, and supervisor social security number. But what I need is supervisor name, right? How do you do that? Yes. Any ideas in the chat, please? So what I can do now is, you can see that this is foreign key, but it foreign key to the same table, right? So that means we have to use employee table twice. Did you get my point? Because supervisor social security number is a recursive relationship, we say. That is a foreign key which references the social security number in the same table. Therefore, we have to provide employee twice. You got my point? So now it's a bit difficult to say anything, right? So if I say employee, that might be a problem. If I say, okay, from employee, comma, employee. This is confusing, right? Because we need to combine. So what we can do is, the first employee table, I will say E. The second employee table, I will say S, right? And then I can specify the combination. So what I want to say here is, I can say, okay, combining is E dot, that means our first table, supervisor social security number should be equal to second one, social security number. So this is what the where clause would be. But now remember, you have to specify what this F number is. So because since it is coming from this, you have to say E dot F name, E dot L name, and we don't need this. But from S, we can say S, let's say L name. So basically we are getting first name, last name of the employee. We'll get supervisor's last name. Now let me run this, see whether we are getting the intended outcome. Okay, we got this. You can see how we get the outcome. Yes, but you can see now we are getting the same names. So we better rename. Let me update this. So EF name, I will rename. Let me say as employee name, right? Employee, we can say first name. And we can say employee last name. And then we can say supervisor. Supervisor name. So if I rerun this will be much better now. You can say employee first name, employee last name, supervisor name. So I hope this explained to you the use of renaming operator. So let's say we want to find out name and address of employees who works in the research department. First, let's take, employee table. How do you get that? You can say select all from employee, right? So this is what we get. Now you know that if you get this information, we have department number 5, okay? And let's take everybody from department number, select all from department. So if you refer these two tables, we might be able to answer this question. So we know that, okay, John Smith works in department number 5. And if you go down to the department name, department of research. So what we really need is to say, okay, John Smith is working in the research department, right? Okay. So if you need everybody, right? Let's say in this particular case, we are asking name and address of employees. If you need just only that, we can say, okay, name and address, right? So what we can say is, let me say first name, last name, sorry, L name, and then we say address. So if you try this way, you can see we are getting first name, last name, and address of employee. But the problem is we don't need everyone. We need those who work for the research department, right? So first we'll get, let me make a change of this. Let me use combination of this. We have to combine. What do you need to combine? We need to combine both employee and department. Where we can have the joint condition that this department number should be equal to department number. So if I run this one, so now you might get, okay, let me put we say department name. So you can see that if you put in this manner, what happens? We get everybody right here. We get first name, last name, address. If you look at everyone, not only research, we get others as well. But then again, if you want to limit research, we can say department name should be research. If you put in this form, what happens now? Right? We get all those who works for the research department, right? You can notice. And if you just say name and addresses, you can remove this. This is the final answer for this. This will give you a list of name and addresses of employees, those who works for research team. Right. Any question on this? Right. Okay. Shall we move to the another one? Now we were discussing about joint operations. The same thing we can do it, separate out joint operation. Now who you can see here, this is called joint condition. This is called joint condition. So we can use joint keyword to specify joint condition. So same thing I can written in another way, which I'm going to separate out the connectivity. So this is the second way to do this. Select first name, last name, address. From, okay, here we have to specify joining condition. We will say employee will join with department on department number should be equal to department. Hope if this is working, let me check if this is working. Employee join, that is a mistake file, typing mistake. So same idea, but our filtering is not here. So where are close, we will specify only department name. Should be research. So now you can see it will be identical to the previous one. Okay, if you finish up to this point, right. So we are talking about the join operations. I want to talk about other types of joins. So for example, we can say, okay, select first name, comma, last name, address, from. Okay, slight difference. We can say employee then natural join department. So if you do this, let me see what will happen. Okay, we are going to get an answer here. Same answer. What happens here? Simply what it does, right? It combines both the employees together with the department. So simply combine the two. Naturally, you join employees to the department by considering the joint condition value. So this is another way you can combine both employee and the department. Okay, with that said, we can talk about some aggregate functions. So, for example, let's say we are interested in getting salary values, right? Let me run again, salary values. Of course, you can get maximum, minimum, and average values without any problem. So these are called aggregate functions. Aggregate functions. Right? For example, we can say, okay, I need salaries, right? So we can say salary, select salary from employee. So what happens if you run it? You get salary values like this, right? Okay. But then again, you can say, okay, what is maximum of this? If you go through this, what is the maximum? Okay, 50,000, 55,000. So you type max salary. So if you run like this, so it says max salary is 55,000. That is max. So you can get others as well. So you can say max salary, min salary, then AVG salary, average salary. So if you run this, you can get max, mean, and the average salaries, which is quite useful. So let's say I need the, this is all salaries. I need the min max salaries of the research department, slight alteration. So I will say, okay, select, we'll copy save. We can say where department number equals 5. Equals 5 means research department, right? So let me run both. Semicolon, I miss. Okay, so we are getting so you can notice that the first one provides us maximum minimum salaries for all the departments. And here we will get max mean average. Yes. Those who works for the research department. Right. So these are what we call the average values. What you can do is you can even count number of times here as well, right? So for example, let's count. Okay, let me put it this way. Um, list department number of employees in the department, number of employees in the department, and then average salaries. There was a good question from Nirmal in the chat. Usually, natural join meaning in other databases, meaning with natural join, you don't have to specify attribute names. But Nirmal, in Oracle, when you use natural join, it looks for similar data domain, which means data types. And then it does select and join them naturally. So this might create other issues as well, but for the time being, that's what happened between the natural join. So as you said, I totally agree. When it comes to large databases, yes, you can have a unique set of names so that you are going to miss this part. Otherwise, what might happen in natural join, in Oracle especially, it looks for similar data types we call domain of data, and it combines it. It's always better you use unique names in the beginning. But remember, now the process is mostly agile. Agile means what might happen when you keep on updating, you might add new tables with names, but sometimes you cannot change the names what is already existing because some of the codes already developed are depend on it. So you might have a situation like this. So it's always specifically, separately make join will be the effective way. I think that's how you should, look at the situation. So as you can see, you can use, it's always good to make, unique field names. But when you evaluate, then there might be confusions. So sometimes this might not be possible. So when you have like same name, doesn't matter because you can refer. If it is, you can't have same names in the same table, right? But then in several tables, you can have the same name where you can use different table relations. So you can use table name and then the attribute name. So in that way, you can combine. Okay, so having said that, we what we did so far is, okay, we want to list the department number of employees in the department, right? We want to list the department number, right? And then we want to have average salary. How do you do that? So one thing is we can say, okay, we can have select department number of employees, we mean count. If you remember this count, okay, maybe if you just count, it comes like this. Let's say select count all from employee. So what this means is you count the number of employees in the table and it says 8, right? But let's say you want to have department number and count from employee. But then again, if you just put it, that will create a problem because to apply this, you have to first order in the department number. Slight modification I'm going to put. So let me put this is group by department number. hope this should, yes. So the error I got earlier is like it's not ordered properly by the department number before we apply the count. So outcome you get is you have one employee in the department number 1, 4 employees in the department number 5, and 3 in department number 4. Okay, let's say I need average salaries, right? We can update this one. Let's say I need list department number, number of employees, and average salary, right? If that is the case, you can use the same thing, but except you can put average salary. So you can say average. So which will average out the salary for each of these different departments. So department number, we have 55,000. Department number 5, we have 33,000. Department number 4, we have 31,000. Right. Let's move on to the next one. Right. So we were discussing about listing department number, number of employees, and average salary. So I hope now you should be able to work on this. But remember that this group by is very, very important when it comes to aggregation. So for example, if you can, sometimes you can have more than one grouping. So that is also possible. For example, let's say when you have uh, the values that you want to apply, then you can use the grouping and then you can have a list of attributes. For example, let's say we want to get project number, project name, and number of employees who works for the project, right? So let's put up like this. So the question that I want you to think about is, let's project number, project name, number of employees, right? Works on projects. So if you would list something like this, we know definitely we can have select, let's say project number, project name. Right. Now what we know is we want to combine two tables. So what are the two tables? We have to say project, right? And then works on. So by combining these two, we should be able to get it. We say where project number should be equal to project number. So if you run this, see what will happen. We have project name, project number. So we have project number, project name, product X, 2, 3, 20, and so on. But let's say we want to make it a count using both, right? Project number and project name. So one way to update these is project number, project name, and then the count. Right. So we can group by project number, project. So you can notice that, right? There are 3 employees works for project number 2, 3 employees works for project number 30, 3 employees works for project number 20, right? That will give you the count name. Right. Now, let's say we don't want everybody. Let's say we want to list only the projects who have more than 2 employees, right? So let's limit this result in a grouping. So then you can use what we call the having clause. So what we want to do is, let's say in this particular case, we are retrieving everything. What do you mean by retrieving everything? That means we get, right, projects, their project names and number of employees. Let's say we need to list only project based on the number of employees more than 2, right? Then you can apply having clause. So when you say having and the number, we can say count, let's say greater than 2. So now what do you expect? When you run, you will notice that, okay? So on this time, we will get only 4 projects where we can see there are more than 3 employees, more than 2 employees are working on a project. Right, good. Okay, so having said that, let me finish my discussion by having 2 more things. One is if you want to compare based on substrings, which we call similar, like use of like operator, which I have discussed earlier as well. But let me discuss one example, right? So point I want to make something like this. Let me take a new one. Let's say we want to get all the employees, list all the employees whose address contains Houston, Texas. We have already discussed this idea. So how do you do that? We can say select, let's say name, first name and last name, just the 2 name. If you do the select first name and last name, we can say from employee, where if you know the address, we can say equal, and then you can put a colon and values. But in this case, we don't know exactly. So when you want to say exactly, right, you use percentage symbol. The idea of a percentage symbol is it can represent 0 or more characters, right? That's what you need to remember. So if you put in this way, and let me put address as well, right? If you do this way and if you run this, yeah, now you can see it will list all the persons whose address contains Huston, Texas, right? So I think I can remove this part now. So you can see we know that only 3 employees works on address like Houston, Texas. Right, now let's say we want to update the results, right? We have to specify the order. I think order we have discussed there as well. But let me give you example and finish my discussion while ending our session. So let's say we want to have some data and we want to order based on predefined set of attributes. So let's say we want to get department name, employee names, and their project names, right? If you want to get that information, we have to connect multiple tables. You want to get a department name, last name, first name, and project name, right? So if you have a situation like this, what we could do something similar to this. Let me say select department name, last name, first name, and project name. Because we know that same person can work on multiple projects, right? So we have to combine how many tables there. Now, if you want to get the department name, employees, you have to combine both the employees and the departments. And employees works on projects. So you have to use projects and then the connectivity is in the works on. So which means we have to say, okay, from department, employee, right, works on, then project. So we have to combine all these together to get an answer. So 4 tables means we have to have 3 joint conditions. So let's put 3 joint conditions. What are the 3 joint conditions? We have to say department number equals to department. And social security number should be equal to employee social security number. Combining works on. And project number should be equal to project number. Right? And then you can say order. So we say order by, we specify first, you try to, you first order by department name, then last name, then first name. So let's see how this works. If you run this, yes, you can see administration. Jabba Ahmed is working on 2 projects. Like same administration, Wallace works on 2 projects. Administration Selaya is again 2. Headquarters Bogs 1. Research English Choice Productex 2 projects. Narayan 1 projects. Smith Dome 2 projects. Wong you can see 1, 2, 3, 4 projects. Okay, so I think with that, I will conclude my discussion on relational databases with Oracle SQL. I think in this short 6 session, 2 hour sessions, we were able to cover starting from getting database description to database conceptual design to logical mapping to physical database, right? And also we discuss Oracle SQL in particular, how we can construct database tables as well as querying them. So I hope what we have discussed in this module were very useful. Yes, Nirmal, we are not actually focusing on any database optimization in this. Yes, of course, in advanced one, we can talk about this. For example, we use select all from employee. We never use in cloud environment, which cost a lot, right? Small things like that, we have to be very careful. So maybe, yes, we can discuss in a separate one, or maybe you could request and we can discuss about how to, learn those. But you need like little bit of mathematical details as well when you talk about the query optimization, which we have not covered here. But you need to, because SQL is a structured language, we have to put it down to what we call the relational algebra, which you can go to atomic level to optimize your queries. Anyways, it's a pleasure to working with you. Some of you put up questions asking me. I can see that you are putting a lot of related questions, which I'm happy to have them. And wish you good luck for the tomorrow's session. As I promised you, I will share you uh, the quiz as a practice quiz so that you can practice and come so that you are get ready for the final assessment. So until such time, so let's finish for today. And thank you, everyone. We'll meet tomorrow with the last session.